One of the key factors that affect the growth of a plant is the ability to absorb the nutrients. These nutrients like potassium, nitrogen, and calcium might be available in the soil, but it takes some activity in the soil so that the plant might be able to use them. As part of the course, me and my colleague Adonias, we had an opportunity to investigate the product that can make this plant to be able to absorb the nutrients and use them in the soil. We had an opportunity to do a project, an investigation project on the production and the testing of a biostimulant obtained from an oxidation plant. In the quest to practice more environmentally friendly agricultural activities, there have been rise in production of biostimulants in agricultural sector. But the question is, what is a biostimulant?
Biostimulants are substances or microorganisms that can be applied to different plants with the aim of increasing nutrition efficiency. It helps to decrease the impact of biotic or impact of living things that come to the plants. And also it helps to reduce the abiotic impacts or the negative impacts of non-living things that come to the plants or what the plant can face during their life cycle. So biostimulant can facilitate the accumulation of nutrients by supporting the metabolic processes in the soil in the plant. So they use to improve the crop quality as well as they regulate the growth of the plants. On the methodology, the raw materials were identified from the school oxidation lagoon of the farm which is located in the aquarium. The extraction of the biostimulant was done by hydrolysis process at the University Laboratory. It is important to note that biostimulants can also be formulated by fractioning like fulvic and humic acid.
The formulated product was then tested in Lekasa, which is part of the academic farm at Art University, whereby it was applied 2 times per week for 4 weeks to test its effectivity on the growth of the lettuce plant. The variables that were analyzed after 5 weeks of the growth of the lettuce plant was the height of the plant, the number of leaves of the lettuce plant, the breadth of the plant, and the root development. These were then evaluated using the R studio with a significant level of 0.05. Well, in our case, the formulation of our product was done by hydrolysis process, whereby the plants from the oxidation plant, that is the water hyacinth and the water lettuce, were collected and dried under a shed. That is very important in order to not to tamper with the properties of what we want to use from this plant. We did this to avoid direct sunshine with the plant. 200 grams of dry ground oxidation plant, that is the combination of the water hyacinth and the water lettuce, were used, whereby 100 grams was extracted by potassium hydroxide and the other by sulfuric acid, and the two are combined. In the case of sulfuric acid, 1 liter of water was added to dry matter, followed by 50 milliliter of 0.5 molar of sulfuric acid. The mixture was then boiled for 20 minutes and left at room temperature for 48 hours. The procedure, the same procedure was used by the preparation of potassium hydroxide, whereby the two are mixed in equal proportions, and the formulation was completed by adding specific amounts of diammonium phosphate, urea, potassium nitrate, and citric acid. Also, we used xanthan gum and potassium sorbate. The pH was regulated by the citric acid. The effectivity of the product that was formed was evaluated in academic farm, that is Lekasa, at Earth University.
we made different concentration because from the analysis of other scientists, there's an effect of a biostimulant formed by the water lettuce and water hyacinth, but we really don't know at which concentration will be effective to the plants. So we were evaluating different concentrations of the plants or different concentration of our product in relation to the number of leaves, the height, the breadth, and the root development of the lettuce plant. The randomized complete block design was used on the 3 selected blocks. The product was then applied for 2 weeks, and the analysis done after 4 weeks of the time of planting. The collected data per treatment was then evaluated by RStudio program and analyzed by ANOVA, where the means of different parameters used were determined to get the best concentration of the product used for the growth and development of the lettuce plant. When we go to, we use the RStudio with a significance level of 0.05. So we did the comparison of means of breadth of the lettuce using the least significant difference, the LSD test. And as we can see, the table is showing us different breadths and standard deviation and the groups. These are the groups that can be graphed also, as we will see the graph that follows, and the p-value of 0.01599, which is less than 0.05. Just to say, the null hypothesis of our experiment was that there is no statistically significant difference or relationship between different concentration of biostimulant applied to lettuce plant and the growth of the lettuce in terms of height, number of leaves, the breadth of the plant, and the root development. The alternative hypothesis was that there is indeed statistical difference relationship between different concentrations of the biostimulant applied to the lettuce plants and their growth. For the table above and the graph that is, and the graph below, we notice that there is statistical difference on the breadth of the lettuce crop in different concentration of biostimulant indicated by p-value of 0.05. This is also indicated by 100 milliliters being recording the highest breadth and being the best of the concentration. This was done because at the market level, people look at how big the plant is, and that's how they are attracted. We went on to the comparison of means of the height of the lettuce plant, and as we can see, we had a p-value of 0.8072, which is higher than 0.05. So there's no statistically difference between the data obtained by different concentrations. Therefore, what can we say? The variable height presented by p-value 0.08 shows that we had which is higher than the value of significant level 0.05, clearly indicates that there is no statistical difference. So the height of the plant was not affected. There might be because we did this analysis when the plants had already reached their maximum level, because the life cycle of the lettuce plant is 5 weeks. The graph indicates the number of groups graphed from the table. We did also a comparison of root development, and this is where it got so interesting, because generally the biostimulants are known to help in the root development. So when we see like this, we see like all the 3 biostimulants had an effect on root development, except the treatment which was not applied, which shows the least root development test. So, and we can see there is 0.0003 as a p-value compared to 0.05, which is the significance level that we use. So this means we have statistically different data or different statistics of treatments compared to the test experiment. We had no preferably good biostimulant. All of them were good, and they showed stimulation of the roots. Also, we did with the comparison of means of the leaves. Now, this gets so important because the number of leaves are very important to the plants, whereby the relation of the concentration of biostimulant here represents 0.02. However, this will show that we don't have any difference in, statistically on the number of leaves. But when we go on the graph, we get that 100 milliliters showed a higher number of leaves compared to the others. So that means having the best development of roots and also recording the high breadth, it means that the 100 milliliters was the best of all. So in conclusion, from the data generated below, we can deduce that 100 milliliters had the best was the best concentration compared to the 50 milliliter, the 100 milliliter, the 150 milliliter, and the 0 milliliter. So this is in conjunction with the investigation projects done by Nguyen and Ofor, who did the effects of biostimulants to the growth of plants, and they evaluated different parameters in which we also based on. And they really, they also noted that there is an effect of biostimulant on the growth of plants, and also there is also an increase in the number of leaves when plants are applied by biostimulants. There is root development, and also we have also some increase in the breadth, as in the number, as it is in the number of leaves. So it is important actually to put ourselves into this world of biostimulants in order to save the environment, because these are very environment free. They have been recommended by the European market of fertilizers as one of the safest means of trying to deal with the environment. So the adjustments were also made whereby we were not able to measure a lot of parameters as we had wanted before. It is because of the pandemic, the COVID-19. Also, we were late in terms of formulation of our product, and the time that we had scheduled to put ourselves into an analysis in the field was also short. But all in all, we had an opportunity to finish our project, and we had an opportunity to have good data. Thank you.
As a recommendation, project plan is important to determine the result, and the field analysis is also important in case of the agriculture product.
It's also important to know the soil analysis and the foliage analysis, because those are very important factors that will affect on the results that we are going to have. It's also most important to note that more parameters, as in our project, should be analyzed in comparison to other biostimulants too. That will give us the effectivity of our product and also market it for more results. Bon appetit.